Yeah, hello everybody. Welcome to my channel again. Today we want to discuss on how we can download Global Digital Elevation Model (DEM) and on Google Earth Engine, and how we can cut our or clip our study area from it, or better still, how we can download the digital elevation model on Google Earth Engine for our study area. So we know digital elevation model is very useful, data for many purposes. If you are an engineer, you construction of roads, you need digital elevation model to know where to construct your roads on the terrain. If you are into hydrologic, you know, water basin, you need a digital elevation model to to model your watershed. If you're working with telecommunication industry, you need a digital elevation model to know the height of where you're going to place your mast for optimum services and all that. So without further ado, let's jump into it. Here we are in the Google Earth Engine data catalog. Here you can see we have access to different data which are pre-processed or something. Some are just raw data, some are pre-processed data which you can use or you can acquire for your usage and for your project, for any activities you want to use it for. Uh, Here we have okay, this is what we are looking for: STRM digital elevation data version 4. Now we can look at it. Now let's read about it. They said the shuttle radar topography mission STRM digital elevation dataset was originally produced to provide consistent high quality elevation data at near global scope. This version of the STRM digital elevation data has been processed to fill data void. So this is telling you that you don't have any part of this global data of DEM that is data void. So let's take a look into it. Okay. So the data set is a STRM digital elevation data version 4. Dataset availability, it's available from year 2000. You can have it from year 2000. The data provider is NASA and SIGA. These are it's a collaboration between NASA and SIGA to produce these data, this SCRM digital elevation model. And the Earth Engine SNPnet for it. There's the Earth Engine SNPnet for it. So and the name is elevation, the band name elevation, the unit is in meters, the minimum value is minus 444 meters, and the maximum is this. The pixel is in 90 meters, and description is elevation. So the code, Java code to see it, oh, there is it. So what other information can we have? This is that's the band information. This is the description here. We have the band information. We have the terms of use. If you are using this data, it's good that you go through the terms of use, and if you want to do cite, once you're using this data, once you use this rather, you have to cite this citation. You have to provide it, so that you don't violate the owner's rights, at the end of the day. So let's see how we can download this data. That's the SCRM digital elevation data in Google Earth Engine. So let's route into Google Earth Engine. So within the Google Earth Engine interface, we have this. There's Let me see, I think I saved the script somewhere here. Yes. Okay. Okay, so we have this. Now, for here, say VAR NGR, this is NGR, I rename it anyway as Nigeria. That's I here I have a shapefile of Nigeria. I downloaded the digital elevation model of Nigeria here. So I downloaded that. This is the shapefile of Nigeria here, but we are not working with the shapefile of Nigeria. Let's remove it. We are going to remove it. Okay, we remove it. So let's let's download the digital elevation model for an area. Let's look at what we have. I'm just looking for an area. Okay, let's do somewhere around here. Let's do somewhere around there. There's a Missouri River. Let's just take somewhere that have okay, let's do somewhere around here. So we are going to take our study area. You can upload your if you have a shapefile, you can upload your shapefile. If you don't have your shapefile, if you know your area, your study area, you can just take any of these two. There is the triangle tool. There is the to draw, a freehand drawing, a kind of drawing tool. There is the drawing a line. There is the a point. I had a marker, and this is the pan. So you can reduce if you want to view more areas. Let's see. Okay. Okay, I'm interested in somewhere in Africa. So let's zoom this up. Let's see. So let's take somewhere in Nigeria. So let's go somewhere in Jeba. So we are taking somewhere in Jeba. You click geometry. You can change the color of your geometry if you like. Okay, into geometry. Then we say, let's come here. Let's say we're taking here. Let's say we're taking here. Let's take this place as our study area. Now, since we take this place as our study area, you see, once we draw the study area out, we have automatically created, it automatically created a var, a command for the study area. VAR geometry, GVR geometry is the default name, geometry, and it's a polygon 4 vertices. It's a polygon here, it has 4 vertices, so that's why it's a polygon 4 vertices. Now you can decide to leave the name as geometry, which is the default name, or you can decide to name it as to give it your own name. But for me, I would say let it be ROI. You can decide the name you want to give it. I'm giving mine ROI. Now let me remove this elevation data. This is the elevation data. Let me remove and bring it up. I'm bringing it up. So we go here, NASA. Oh, let's see the name. Let's see the name here. SDRM, Digital Elevation. Let's copy this. SDRM Digital Elevation. Okay, this is it. SDRM Digital Elevation. So let's see it first. So the same information we got from here, we can also get it from here. So it tells us the dataset availability. It says start having this data from 2000, year 2000. There is and the dataset provider, NASA, and in collaboration with SIGA. And we have a collection SnapNet. This is the collection SnapNet. The description here, the bands we have, and it's only one band. That's elevation band. The terms of use, the citation, which we have already seen at the other on the catalog. Then we can say we import. If you click import, this is it. It's a VAR. It's image. Image. And it's a image. This is the name. Image. The default name. Image. And this is the it's one band. Just one band. It's a single band. And this is the elevation data. So so for me, I will change this image to DEM because you can use any name. You can leave it as image. You can use it as image. Okay, let's leave it as image. Okay, DEM. You can say DEM underscore IMG. Sorry, IMG. Click out. DEM underscore IMG. So our DEM data, we name it as DEM underscore IMG, and our shapefile, that's our study area, we name it as ROI. We can leave it as default if we can work with it like that. But for for us to understand it, full understanding and easy understanding, we can say, okay, let's change it to something we are familiar with and something that when we see, we will be able to know what it means. So now the first activity we want to do is we want to add layer. We want to map this. We want to take this what's it called, the data of our study area. Now we say var dem underscore clip. Now this is not a function, it's just a name. We are saying that we want to clip our study area from this digital elevation data of the whole world. Dem, so we can say dem underscore clip. You can write anything here, something that will just give you a quick understanding of what you want to do. For me, but I know it's the dem data I have, and I want to clip my study area. I want to cut my study area away from it. So we say dem underscore clip equals, what is this? You copy this. It's case sensitive. If you don't really work with the case, you can have problem. We highlight that, we paste. So we are defining that we want this DEM clip means that we want this digital elevation model data, which we have said DEM underscore IMG equals the digital elevation model data, the global data. Now we now say DEM clip. We want to extract our study area from the global DEM data. So we say DEM image. That means we are calling this out. We are calling this data out. Dot clip. Now, if we are clipping this our ROI. You copy, then you change this. You see? You say DEM underscore IMG. You are calling this data out, this elevation data out, and you say clip ROI, clip this study area from heat. This is a function. Then we want to visualize it. Map.addLayer. That's for this DEM clip. We want to see. Here we have called it out, but we are not seeing it yet on our mapping interface. So how can we see it? And that goes for any other mapping scripting that you are running on Google Earth Engine. You must add this function for you to visualize it, for you to be able to visualize what we're doing. So you say map.addLayer, you open the DEM clip, which is this, comma, you put this, and it's here already. The function, what we are going to do is here. This is not a function, it's a statement of what you are expected to do at the end of the day. So we say map.addLayer DEM clip, you put this, comma, you put this, comma, then your DEM clip again. That's them, this, them. DEM clip, DEM clip. And you know that your DEM is this. DEM clip is this, that is this. It's representing this. That's, you are saying from this entire elevation data, clip my study area out. I'm only interested in my study area. I'm not interested in seeing the old data. I'm only interested in seeing the data from my study area. And here you are visualizing it. Now this function is to export it. You want to export it to your to your drive, your Google Drive. You want to export it so that you can download it and use it in your ArcGIS or your QGIS or any of the GIS software you are using. So you say export dot image dot to drive, and that is the function of exporting. That's the syntax, the function of exporting. Now the image, we say the name of the image this image that we are exporting is this DEM clip. You have to be consistent. The image you are exporting is DEM clip. Description, this is the description we gave it, DEM AOI. You can give it any name. The description, we want to describe what you are exporting. I want to export the AOI or ROI. Okay, I say ROI here and put it ROI. DEM underscore ROI. Region will be our ROI. ROI. Scale, we leave it at 30. Map pixel, we'll leave it like this. Then let's run. We run it. And now the task is highlighted. It's ready to be downloaded. So let's run. It's going to be name DEM ROI, that's the task name. is going to use the world reference system, coordinate reference system. The scale will be at 30 meter. The drive folder name, it's just going to this drive, into your Google Drive. The file name that you are going to look for in the drive is DEM ROI. Then you have the format, the file format is GeoTIFF. You can have this TAF record image, but I want it as GeoTIFF. I want it as an image. Then as I click run. So it's running. Depends on how big or how massive your study area is. Then it determines how long it takes to run. But it's running. Let's see. Okay. So let's see if we have our DEM right there. We go to the layer. We see that our DEM clip is already available. Then we go back to our geometry. We open it up and we see. This is our DEM data. So but it is like this. We can come here and say it's blank, evaluation, custom, stretch 90, apply, and close. So this is our DEM data. So we can download it and we can use it for any further analysis that we want to perform. So thank you. Today we've been able to show how to download a digital vision model of your study area from global STRM data, digital vision data version 4. And we're able to show how to clip your study area away from the global data, and also how to export your clip data for further analysis within your choosing GIS software. So thank you for today. Till we meet again. But remember, like our channel, subscribe, and give us a like and share our channel. Thank you very much. God bless you.